So this week we finally use the logical expressions that we spoke about last week. The reason one needs logic in a program is that different things have to be done at different times and decisions have to be taken based on this logic. We used the example of the if statement in this lecture. The data that we used has things that have to be patched, but only in a few places. So we determine with if whether or not anything needs to be done at that particular patch of the data. It also means that we have to loop over all the bits of data to check with the if statement whether in fact anything needs to be done. So we end up embedding the if statement inside a for loop. Multiple curves in a single diagram. So for the last lecture in this lesson, we look at comparing the Ebola incidence, the total number of cases for the different countries. So now we're going to take the data that we have in Ebola and plot many different countries. To do this, we will need if and for. The if statement is wonderfully important in computing. From time to time, when you run a computer program, there must be several different options. Computer programs that can actually just chug through one thing at a time are actually worse than washing machines. So you want to write your code so that the computer program will choose to go this way or that way depending on how things are developing. The simplest possible choice is either you do something or you don't, and this is what we need to do because our West African data has missing data. So let's take a look at that. We see that here some of the countries did not report any data until a bit later on. So epidemic day 0, only one country reported. Epidemic day 9, 2 countries reported, and that was also true in epidemic day 23 up to epidemic day 51, but then from epidemic day 66 all the countries reported. So this bit of missing data is what we need to replace. First, let's look at how the if statement works via some examples. So let's look at this code here. I generate a value A using the random number generator, and if the value that was generated is larger than 0.5, we print a second message. So after A is generated, we print the value of A, and then if the value is on the bigger half, then we print it. So the rand is a random number generator that generates a value between 0 and 1. And if I rerun this, I get a different value each time. It's quite fun to look at random number generators in action like this. If we do it in a for loop, then basically all that we do is to take this code, it's identical code, and we put it in a for loop, and the counter for the loop is the variable k. And this will give us 8 different values. Now we go on and we use this to fill in the missing data. So we're going to loop over all the data values, and we're going to use a function, the isNumber function. This will test whether the data value can actually be read as a number. This is either true or false, and so it is actually perfect in an F test. So whenever isNumber evaluates the false, we must replace the missing element with a number. And I choose 0, but one can do it in many other ways. The isNumber test works only if the argument is a string. But any string converts to a string, so we convert all of the inputs to strings. That means that when we read isNumber, we've read the EBD data as string, using the string function to convert it to string. So isNumber gets the data as if it is a string, and then it sees whether it can read it. If it can't read it, that is, if it's the case that not isNumber is true, then we replace it by 0. That's what we do, and just to confirm that it's correct, we see that the strings have now all been replaced by zeros. Now we've got the data in the form that we need. Now it's really easy. We're going to use plots, so we specify that we're using plots, and we specify that the backend is pyplot. The x values are all the same, epidays. We've extracted it by column 1 in the EBD data. The countries are columns 4, 6, and 8. So column 1, epidemic days. Columns 2 and 3 are the data for all countries. Column 2, the total number of cases. Column 3, the total number of deaths. Column 4, total number of cases for the Guinea. Column 6, total number of cases for Liberia. Column 8, total number of cases for Sierra Leone. So when we do this, EBD cases by country, then is a data structure which has all of the rows and 3 columns. So it's a 3-column array. And there it plots it. It's absolutely straightforward, except that we don't quite like that plot as much as the otherwise, so let's customize it again. So it's already pretty useful, but we do need a legend. We do need to break up the data so that it is scattered rather than lines. And we do need labels, turn off the grid lines, and there we go. Now we see it's not entirely satisfactory because of this legend. So the legend keyword is the one that tells us whether there is a legend or not, and also where it is. We've seen that if we set the legend keyword equal to false, then there is no legend. We don't want to do that, but we want to change where it goes, and for that we use top left. And of course, we might as well save the plot because we probably will use it again. So that's the end of the lesson for week 2. So that brings us to the end of week 2, where you've learned about importing data into Julia and perhaps a little bit about where one can find data on the web. It's also very important that you pay attention to the particular structures in Julia that you've started learning about: the for loop, the if structures, the use of logical statements, and perhaps that you should go away and not only do all the quizzes, but experiment a little bit on your own with making your own programs using these elements of Julia. And that will get you ready for week 3 very nicely.